Let's go ahead now and calculate some determinants. We're going to move on to the exercise here at the bottom of the second page of the handout. We're going to find the determinant of A if A is the given 3 by 3 matrix. And now, normally you'll get to decide how to do this. You'll choose a row or a column to work along. But for this exercise, I'm actually saying, let's go ahead, we're going to use cofactor expansion across row 2 on that matrix. So I went ahead and just recopied the problem on a separate sheet. And we won't always have to write out as much detail as I write here, but I want you at least once or twice to see how these formulas relate to what we're doing, okay? And then we'll find shorter ways to write things down. So determinant of A is going to be a number. And if we expand across row 2, we're going to start with this entry that 0 is little a21. And that I'm going to write it down just so we see how this formula relates. So little a21 times capital C, or I guess they use capital. I'm not sure if they use capital or small letters in the book. I think maybe capital. It doesn't matter. C21 plus, now we're going to go second row, second column. So that's A22, C22 plus A23, C23. So A21, 22, 23 are entries along that second row. Now, you're probably never going to write that formula out. You're just going to focus on that second row and start out by writing that first entry, which is 0, times -1 to the sum of the two subscripts times the determinant of A21 plus A22. A22 is 4 times -1 to the sum of its subscripts, 2 plus 2, times the determinant of A22 plus, now little a23, A23 is -6 times -1 to the sum of its subscripts, 2 plus 3, times the determinant of, these are capital A's here, capital A23. Now, even again, I got a 0. If once I know there's a 0 factor, I don't have to figure anything out there. I'm still going to write it out here just for the record. But now, also, this first -1 to a power, it's going to be -1/3. That's going to turn out to be -1. And the determinant of A21, A21 is the submatrix I get when I remove the row and column of this A21 entry, right? So when we remove the first column, second row, and I can write that as a 2 by 2 determinant. It's going to be 1, -3, 2, 5. And going down the line, I have 4 times, now this is going to be +1 because -1 to an even power is times the determinant of A22. If I remove the row and column of that 4 entry, I have 2, -3, -3, 5. 2, -3, -3, 5. And then we have plus -6 times, we're going to get a -1, because it's -1 to an odd power, times the determinant of the submatrix we get when we remove the row and column for -6. 2, 1, -3, 2. So notice how this -1, +1, these powers of -1 are going to alternate. So that will always be true. Once you know the first one, you always know the signs are going to alternate. And so all this is 0 now. I'm not even going to really, I never had to write anything down there, but now I have 4 times, and when you get to a 2 by 2, we just have to work it out using the formula. 2 times 5 is 10, minus a negative 3 times negative 3 is 9. I'm going to have plus 6, because I have 6 times negative 1, and then for the determinant, I have 4 minus a negative 3 is plus 3. So I have 0 plus 10 minus 9 is 1, 4 times 9 is 4, plus 6 times 7. So that's 42, 43, 44, 5, 46. We get 46. There's a determinant of, so whatever it is, this number is some special number associated to that matrix. All right, now let's go on to the next page. We're going to calculate the exact same determinant again. And I wrote out the exercise on a separate paper. And this time we're going to use cofactor expansion down column 3. So down column 3, I'm going to take this entry, then this entry, then this entry. I'm just going to write out the formula here once. So down column 3, so that's first row, third column, so that's A13, C13, plus A23, C23, plus A33, C33. But really, I really never going to have to write out that line. What we're going to do is just focus on the column we're expanding along. And now I'm also going to introduce my little trick for keeping track of the negative 1 to a power. You would always start with a plus sign at that upper left-hand corner. And then it's going to be a pattern of pluses and minuses. So plus, minus, plus for the first entries, minus, plus, minus across the second row, plus, minus, plus across the third. So it's only these, that column where I need the plus or minus signs. So now let's go ahead and do the calculation. So I'm going to take the entry negative 3, the first position of that third column. I'm going to take negative 1 to a power, but see that plus sign is telling me that I'm going to end up multiplying by plus 1. What, where did that plus 1 come from? That's negative 1 to the 1 plus 3, but you don't have to write out all that detail. Just know it's going to turn out to be a plus. And then I'm going to just go right ahead and write in the determinant of the submatrix I get by removing the row and column of that negative 3. So I'll have 0, 4, negative 3, 2. 0, 4, negative 3, 2. Then I move on to the next entry in the column, negative 6. The little red minus sign tells me I'm going to multiply by negative 1. Okay, where did that come from? Well, that's negative 1 to the 2 plus 3, so that's negative 1 to an odd power. So it'll be negative 1. And then I just go right ahead and fill in the submatrix that I get by removing the row and column of the negative 6. So it's going to be 2, 1, negative 3, 2. And finally, the last entry in that column is 5. And I'm going to take 5 times a plus 1 times another submatrix. When I remove 5's row and column, I have 2, 1, 0, 4. 2, 1, 0, 4. So negative 3 times 1 is negative 3 times, now I compute the 2 by 2 determinants using our formula. 0 minus a negative 12 will be plus 12. I'll have plus 6 times 4 plus 3 plus 5 times 8 minus 0. So this is negative 36. 6 times 7 is 42. Plus 5 times 8 is 40. So I'm going to have negative 36 and 42 is 6 plus 40 is 46. That better be what we got. Yes, that is what we got the first time. So we're going to do one more calculation in the third video for this section. So we'll stop this segment here.